Okay, hi everyone, welcome back to this video series for Cisco ASA firewalls, OSPF Type 3 LSA filtering. The Cisco ASA supports OSPF Type 3 LSA filtering. Follow these steps to use ASDM to configure OSPF Type 3 LSA filtering. Step 1, log into ASDM and navigate to Configuration, Device Setup, Routing, OSPF Filtering. Step 2, click on Add to add OSPF filtering rules. The dialog box shown in figure 528 is displayed. Step 3, select OSPF. Select the OSPF process to be associated with the filter entry. In this example, the OSPF process 1 is selected. Step 4, select the area ID to be associated with the filter entry. In this example, area 0 is selected. Step 5, enter the network address and the subnet mask bit to be filtered in the filtered network field. In this example, the network 10.10.6.0/24 is filtered. Step 6, select the direction on how to, Step 6, select the direction on how the filter is applied using the traffic direction pull-down menu. The inbound direction is used in this example. With this configuration, the Cisco ASA filter entry applies to LSAs coming into area 0. Step 7, enter the sequence number to be used for the filter entry under the sequence hash field. In this example, the sequence number used is the number 1. The sequence number is used if multiple filters are configured on the Cisco ASA. The filter with the lowest sequence number is applied first. Step 8, select the action to be applied to this filter. In this example, the deny action is selected to deny any route advertisement for the 10.10.6.0/24 network. Step 9, optional. You can specify the minimum prefix length to be matched with an OSPF filter in the lower range field. In this example, the field is left blank. Step 10, optional. You can specify the maximum prefix length to be matched with an OSPF filter in the upper range field. In this example, this field is left blank. Step 11, click OK. Step 12, click Apply to apply the configuration changes. Step 13, click on Save to save the configuration in the Cisco ASA. To filter Type 3 LSAs in the Cisco ASA via the CLI, use the prefix list command. After it is configured, the Cisco ASA can control which prefixes are sent from one area to another. The syntax of the prefix list is as follows, as you can see here. OSPF neighbour command and dynamic routing over VPN. OSPF hello messages are sent over multicast by default. However, IPsec does not support multicast over a VPN tunnel. Consequently, OSPF adjacency using multicast cannot be established over IPsec VPN tunnels. Cisco ASA provides a solution to this problem by supporting the configuration of statistically defined neighbors. When you configure a statically defined neighbor, the Cisco ASA communicates with its peers using multicast packets. This enables the OSPF messages to be successfully encrypted and sent over the VPN tunnel. The OSPF neighbors can be defined only on non-broadcast media because the underlying physical media is Ethernet broadcast. The media type must be changed to non-broadcast under the interface configuration. This would override the default physical broadcast media type. To configure a static OSPF neighbour using ASDM, complete the following steps. Step 1, log into ASDM, navigate to Configuration, Device Setup, Routing, OSPF static neighbour. Step 2, click on Add to add a new neighbour. Step 3, select the OSPF process to be used for this entry. Step 4, enter the neighbour IP address under the neighbour field. Step 5, select the interface where the neighbour resides in the interface pull-down menu. Step 6, click OK. Step 7, click Apply to apply the configuration changes. Step 8, click on Save to save the configuration in the Cisco ASA. Alternatively, you can use the neighbour command to specify an OSPF neighbour. Example 521 demonstrates how to use the neighbour command for an IPsec peer located at 209.165.201.2. Notice the warning message in example 521. The command does not take effect until the network type is changed to non-broadcast under the interface. Use the OSPF network point-to-point non-broadcast interface command to accomplish this. Example 522 demonstrates this command. Additionally, OSPF expects neighbors to belong to the same subnet. The subnet requirement is overlooked for point-to-point links because the IPsec site-to-site VPN tunnels are considered a point-to-point connection. The previous command provides the solution to this problem. Only one neighbour can be configured on a point-to-point link. On IPsec site-to-site and remote access VPN configurations, you can optionally use reverse route injection, PRI. PRI is a feature on the Cisco ASA that provides a solution for topologies that require encrypted traffic to be diverted to the Cisco ASA and all other traffic to be sent to a separate router. In other words, PRI eliminates the need to manually define static routes on internal routers or hosts to be able to send traffic to remote site-to-site connections or remote access VPN connections. PRI is not configured if the Cisco ASA is used as the default gateway and all traffic passes through it to get into and out of the network. There are several advantages to running OSPF over an IPsec VPN tunnel instead of using PRI. One of the major advantages is that when PRI is used, the routes to the remote networks or hosts are always advertised to the internal network, regardless of whether or not the VPN tunnel is operational. When using OSPF over an IPsec site-to-site tunnel, the routes to the remote network or hosts are advertised only if the VPN tunnel is operational. Troubleshooting OSPF. This section includes many mechanisms and techniques that are used to troubleshoot OSPF problems, such as several show and debug commands. Useful troubleshooting commands. A commonly used command is show OSPF process ID. It displays general information about OSPF routing process IDs. The process ID option displays information for a specific OSPF routing process. Example 523 shows the output of this command. As demonstrated in example 523, the show OSPF command gives you details about the OSPF configuration LSA configuration, OSPF router ID, and the number of areas configured in the Cisco ASA. To display OSPF related interface information, use the show OSPF interface command. Example 524 includes the output of this command for the inside interface. The output of the show OSPF interface command shows not only information about the OSPF communication on that specific interface, but also other information such as the network type, cost, designated router information, and so on. To display OSPF neighbor information, use the show OSPF neighbor command. The following is the command syntax: show OSPF neighbor interface underscore name neighbor underscore ID detail. To show neighbor information on a per interface basis, use the interface name argument. Use the neighbor ID option to display information about a specific neighbor, and use the detail option to display detailed neighbor information. The interface name and neighbor ID options are mutually exclusive. Example 525 shows the output of the show OSPF neighbor command. When OSPF adjacency is formed, the Cisco ASA goes through several state changes before it becomes fully adjacent with its neighbor. The information that these states represent is crucial when troubleshooting OSPF problems in the Cisco ASA. These states are as follows. Down, the first OSPF neighbor state. It means that no hello packets have been received from this neighbor, but hello packets can still be sent to the neighbor in this state. Attempt only valid for manually configured neighbors in a non-broadcast multi-access NBMA environment. In attempt state, the Cisco ASA sends unicast hello packets every whole interval to the neighbor. If it has not received any hello packets within the dead interval, INT specifies that the Cisco ASA has received a hello packet from its neighbor, but their receiving neighbor's ID was not included in the hello packet. When the Cisco ASA or any router running OSPF receives a hello packet from the neighbor's router ID is received in the hello packet. Two-way designates that bidirectional communication has been established between the Cisco ASA and its neighbor. Xstart, the Cisco ASA is exchanging information to select who will be the DR and BDR master-slave relationship, and chooses the initial sequence number for adjacency formation. The device with the higher router ID becomes the master and starts the exchange, and as such is the only device that can increment the sequence number. Exchange indicates the exchange of database descriptor DBD packets. Database descriptors contain LSA headers only and describe the contents of the entire link state database used to determine whether new or more current link state information is available. Loading. The Cisco ASA is doing the actual exchange of link state information with its neighbor. Full. The Cisco ASA and its neighbor are fully adjacent with each other. All the router and network LSAs are exchanged and the routing databases are fully synchronized. Example 526 shows the output of the show OSPF neighbor command with the detail option. The neighbor in this example is the router with the IP address 192.168.10.2. In this example, you can see that the OSPF state is full and that there were 6 state changes. Additionally, you can see that the neighbour has been up for 26 minutes and 21 seconds. Use the OSPF database command to display information related to the Cisco ASA OSPF database. The command displays information about the different OSPF LSAs. It displays detailed information about the neighbour router and the state of the neighbour relationship. Example 527 shows the output, of the show OSPF database command. As demonstrated in example 527, several external routes are learned from router 192.168.10.2. The 192.168.10.2 router is advertising dual routes for networks 192.168.20.0/24 and 192.168.13.0/24. Example 528 shows the output of the show route command. For this example, the O by the route statement indicates that the route is learned via OSPF, and the E2 indicates that it is an external type 2 route. Example 529 shows the output of the debug OSPF events command during a new adjacency. The first highlighted line shows that a two-way communication has been started to the router 192.168.10.2 on the inside interface, and the state is two-way. The second highlighted line shows that non-broadcast NBR negotiation has been completed and the Cisco ASA is classified as the slave. The third and fourth highlighted line indicates that the exchange has been completed and that the state is now full. You can see here, mismatched areas. Example 330 shows the output of the debug OSPF command during the OSPF transaction where the Cisco ASA output was configured with area 0 and the adjacent router was configured with area 1. Consequently, the mismatch area message is displayed in the debug output. OSPF authentication mismatch. In the next example, the Cisco ASA was configured to perform OSPF authentication. OSPF authentication was not enabled on the neighbour router. Example 531 shows the output of the debug OSPF event command. Troubleshooting virtual link problems. To display parameters about the current state of OSPF, virtual links configured in the Cisco ASA use the show OSPF virtual links command. Example 532 shows the output of the show OSPF virtual links command, while the state of the virtual link to router 192.168.10.2 is down, as you can see here. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.